Okay, so let's look at absorption of lipids. So lipids, I'm going to use a different color. Lipids are fats. Just another word for fats. We know that fats are hydrophobic. They don't like water. And when they're in the small intestine, they are basically in water, so they form large fat globules. Just like when you leave your oil and water sitting there, it separates. Okay. All right, so we have our fat globules, and basically it's just like a big globule thing. The fat is bunched together. Okay, so when the fat is globbed together like that, the enzyme that chemically breaks down fat, called lipase, can't really get to the fat. It can only get to the outside of here. It can't get inside of here, of this fat globule. So this is where we need bile. So bile emulsifies the fat. Emulsifies the fat. Or breaks it down into little tiny globules. So with bile, then we just get we've broken those globules apart. So now the lipase can get to it. But lipase is a hydrophilic substance. It likes water. So lipase actually needs some help in order to bind. And it uses something called colipase. And that helps it stick to the fat. Okay, so now we have that, and basically what's happening is we're breaking down the fat, which is basically triglycerides, and we're breaking it into long and short chain fatty acids. So long chain fatty acids and short chain fatty acids, and then monoglycerides, which is basically the glycerol backbone and one fatty acid. Okay, remember, a triglyceride is a glycerol backbone with 3 fatty acids hanging off. Remember, fatty acids are just long chains of carbons. Okay, so now the bile, there's some things in bile that are used, phospholipids and cholesterol, and the fatty acids, the long chain fatty acids and the monoglycerides are wrapped up in phospholipids. Short-chain fatty acids can actually go right into the cell. So if this is our cell, so here's our enterocyte. And short-chain fatty acids, these guys here, can go in. The long-chain fatty acids and the monoglycerides, or the monoglycerides, are wrapped up in something called a micelle. So a micelle is a little sort of ball So these are phospholipids, and inside of there is the fatty acid or the monoglyceride. And these guys go into the cell. Once in the cell, it goes into the smooth ER. And in the smooth ER, once it's there, once in the cell, so once inside the cell, the smooth ER assembles the monoglycerides and the fatty acid chains back into triglycerides. Assembles the monoglycerides and fatty acids back into triglycerides, which are going to look like this. Glycerol, fatty acid chains. Okay. All right, so once it's in there and it's gone through the smooth, or it's in the smooth endoplasmic reticulum or smooth ER, we're getting triglycerides. Now the cell is going to make this sort of boat for the triglycerides to travel into. And it's going to make it out of phospholipids and cholesterol. And what am I doing? Here we go. So we have these, here's our phospholipids, and we're making this big boat thing. For travel. Okay, and inside of here, we have our triglycerides. And there's cholesterol in there. Okay. Now, this is what's going to travel through the blood to get to the liver, fat cells, or whatever. But it can't really do that because this is all fat, and fat can't ride in the blood. It's too watery. So on these boat things are these little proteins that are kind of sticking out of there. And these are called apoproteins. And it allows this thing to be able to travel through the blood. So this thing is called a chylomicron. And remember, this is in the cell. We're making it in the smooth endoplasmic reticulum. So this chylomicron is going to leave the cell. And it's going to go into, it can't really go into the blood. So we're in the our cell. This is the we're in our cell in here. Here's our little microvilli or whatever. Here's the cell, and got our little blood around here. And this chylomicron is too big. It can't get into the blood vessel. It can't do that. So instead, it enters the lymphatic system, and it enters it through the lacteal. So it enters the lymphatic system and flows through the lymphatic system until it's dumped into the blood up by the subclavian vein in the neck. Okay, so it goes into the blood. This chylomicron is basically a lipoprotein, sorry. So this is a lipoprotein. It's lipid, and then there are proteins hanging off of it. Lipoproteins are what carry lipids around the body. So this lipoprotein, this chylomicron, is going to carry this fat in here to the liver, to fat cells. And once it gets there, it's going to be in the blood, and it's going to contact on the epithelial tissue. There's going to be a special type of lipoprotein lipase, and it's going to break down these triglycerides into fatty acids and glycerol for the liver to do whatever with. So the liver or fat cells, if it's fat cells, it's going to reassemble it. Fat cells are going to obviously reassemble it into fat, storage fat, which is triglycerides. Or in the liver, it can either reassemble it into triglycerides to send it for storage, or it can use it for energy. Okay. So basically that's what that is. Lipoproteins, they're categorized by how dense they are of particles. So if they're lower density, or the lower the density, the greater the concentrations of fats inside. The higher the density, the less amount of fats that are inside. Low density lipoproteins, they have a high concentration of fats and transport fats from liver to fat cells. High density lipoproteins contain low concentrations of fats and carry fat back to the liver for recycling and excretion. Okay, and that's about it for fat absorption.